Hello everyone, I want to welcome all of you grade 11 students to the as well as parents and visitors to the virtual math exhibition for the academic year 2020-2021. I was happy and satisfied with most of the work and I tried as well as you did and as much as I can to improve your work. I know things were not easy as most of you were working far from each other, but this was passed mostly by online meetings that you did as a group. So I want to say thank to all of you for all the efforts you did and hope that all of you learned something from this project. So now we will start our exhibition with a short video from Dr. Nigat, our math department HOD, head of assessment and SLT member.
Good morning. Assalamu alaikum everyone. Dear students, teachers, SLTs, principal, HODs and parents. Welcome to Virtual Math Exhibition 2021. The goal of NAR's Math Department is not to increase the amount of knowledge, but to create the possibilities for a child to invent and discover, to create men and women who are capable of doing new things. Education is not the learning of facts, but the training of mind to think. Children must be taught how to think, not what to think. This event provides the students the opportunity to showcase their creative abilities while reflecting the skills they learned during their math lessons. Good luck, students.
So, as we have four projects, grade 11A and C, this means we'll have four videos. We'll start displaying the videos now, and we'll start with video number 1.
Good morning. We have been asked to produce a project for our math fair. So in our project, we'll be discussing about trigonometry. This project is done by Yasin Abdulrahman, Hamad Hisham, Hamad Badr, and Walid Mizhar. So at the beginning, what is trigonometry? Trigonometry is a branch of mathematics that investigates the relationship between triangle side lengths and angles. In trigonometry, there are 6 functions of an angle that are widely used. Sine, cosine, tangent, cotangent, secant, and cosecant are their names and abbreviations. What's the reason behind studying trigonometry? The study of trigonometry involves learning how to measure the angles and dimensions of a given shape using trigonometric functions, such as the sine or cosine of an angle. They may also have these tasks in practical exercises to help students improve their skills.
And now we'll be talking about the history of trigonometry. The word trigonometry comes from the Greek word trigonon, which means triangle, and metron, which means measure. In the 16th century, trigonometry was chiefly concerned with computing with numerical values of the missing parts of triangle when the values of the other parts were given. Trigonometry started from several ancient civilizations, including the Egyptians, Babylonians, and the Chinese civilizations. They had extensive knowledge of practical geometry, including some of the introductions of the trigonometric concepts. According to the researchers, the Egyptians had at least basic understanding of the numerical relationships in triangles, a kind of proto-trigonometry. Then, trigonometry began to shift from purely geometric discipline to an algebraic analytic subject in the 16th century. And this was developed by a French mathematician, François Viet. And the invention of analytic geometry came by two other Frenchmen, Pierre de Fermat and René Descartes. And in the coming video, you will be watching an example of a mathematical application.
So as in this question, we're going to apply law of sine, which is sine A over A equals sine B over B equals sine C over C. And this question states that triangle named PQR, which is drawn in front of us, has angle P, which is 63.5, and angle Q, which is 51.2. And he gave us as well the side R, which is 6.3 centimeters. So now we want us to find the other two sides, Q and P, and the unknown angle, which is R. Let's start by finding the unknown angle, which is R. Now, as we know, any triangle has a total measurement of all angles 180 degrees. So 180 equals 63.5 plus 51.2 plus the last one, angle R. So now we will subtract from both sides and we will find that R is equals to 65.3 degrees. Now, moving to the last part of the question, which we will find the other two sides. In order to find the other two sides, we will use the law of sine, which is this one. So, we will start with sine P, which is sine 63.5 over P, which is unknown. Then sine R, which we just found is 65.3, over R, which is given in the question, 6.3 centimeters. Then the last one, sine Q. Sine Q, which is sine 51.2, over Q, which is unknown. Now, in order to solve this equation, we need to split it into two different equations. The first one will be this one, and the second one will be this. So, let's start by solving the first one. 6.3 times sine 63.5 divide sine 65.3. We'll find out that P is equals to 6.2 centimeters. Then, solving the other equation, we'll multiply 6.3 by sine 51.2, divide sine 65.3. We'll find out that Q is equals to 5.40 centimeters. Now we've found all the required parts of the question.
And now we are going to take some real-life applications. The first one will be on how trigonometry is used to measure the height of a building or a mountain. If the distance from where you observe the building and the angle of elevation is known, you can easily find the height of the building. Similarly, if you have the value of one side and the angle of depression from the top of the building, you can find another side in the triangle. All you need to know is one side and angle of the triangle. Another example is trigonometry in flight engineering. Flight engineers have taken account their speed, distance, and direction along with the speed and direction of the wind. The wind plays an important role in how and when a plane will arrive wherever needed. This is solved using vectors to create a triangle using trigonometry to solve. For example, if a plane is traveling at 234 miles per hour, 45 degrees north of east, and there is a wind blowing due south at 20 miles per hour, trigonometry will help to solve for that third side of triangle, which will lead the plane in the right direction. The plane will actually travel with the force of wind added on to its course.
Connection with other subjects. In physics, trigonometry is used to locate vector components, model the dynamics of both physical and electromagnetic and oscillations, sum the intensity of fields, and use dot and cross products. In engineering, angles are often calculated using trigonometry principles by engineers. Trigonometry is used by civil and mechanical engineers to measure torque and forces in structures, such as bridges or building girders. daily life use, building roads in some cases requires the civil engineers to use trigonometry. In this scenario, the engineer is asked to build a new road that will allow cars to travel from one side to the other. Furthermore, in order to build the road perfectly, this job necessitates the use of all angles and sides.
distance between the buoy and the bridge, so we will displace it by the... We will produce a model which is related to our topic trigonometry using Pisa tower and the model of a man, and we wanted to calculate the distance between the man and the pillar of the tower. So in order to calculate the distance between the man and the pillar of the tower, we need to use the law of cosine. The law of cosine states that a squared equals b squared plus 6 squared minus 2bc cosine a. So we need the angle of the tower, the angle between the tower and the floor and the ground. So we replaced here. We have some givens, which is the distance between the man and the tower. It's already given, and we have the tower height. It's already given as well. So all we have to do is replace all these numbers, and we will get that a squared equals 732. We put a square root, and we'll get that the distance between the pillar and the man is 27 meters.
In this project, I was in charge of filming Yasin while explaining, and I edited some videos as well. I was also responsible for introducing the topic, defining trigonometry, and clarifying the reason of taking this topic in our curriculum. While doing this project, I faced some difficulties, so I had a problem in how can I introduce the topic in a way that would grab audience's attention, and it was somehow hard to define trigonometry using my own words. What I learned is how to make a definition of mathematical vocabulary using my own words and how to combine ideas together to convince students about the importance of trigonometry.
In this project, I was responsible of shooting the video with Walid, along with gathering information and editing the video. While working in the project, I faced a number of difficulties, including editing the video, searching for ideas and information, and figuring out how to balance the time of studying and working on the project. Despite of the difficulties, I have learned several things from the project, such as what trigonometry means, where it came from, and how trigonometry is used in our daily lives, as well as new skills in video editing.
I was a part of creating the model and the PowerPoint. I personally went through many difficulties during this project, starting from the pressure of school, including homeworks, quizzes, projects, and fairs altogether. I also had some problems with the time we had as we made another project for some reason. I basically learned some new things while working on this project. Working as a team and dividing tasks equally improves the outcome of the project. Second, as a student that's looking into studying civil engineering, I learned that I'll be using trigonometry on most of my work.
In this project, I was responsible of making the model and explaining a mathematical application question. While doing this project, I faced many difficulties that were making it harder for us to achieve a higher score. Mainly was the pressure of time. In addition to that, it was my first time doing such a project, so I was lost and not knowing from where and how to start working. I built the model, and that took me a whole day, even though it was simple, but it was me who was lost. In this project, I learned many new things, and I improved many different skills, including time management and leadership skills, which are one of the most important skills in life.
Thank you very much. Now I want also to ask the leader of this group to give us a brief reflection for the whole group about this project. Can I ask Yasin to open the mic and can, if possible, and tell me the reflection of the whole group for this project?
Yes, Mr.
Can I start this?
Good morning. My name is Yasin. I'm from grade 11A. This competition to be number one project was very interesting and competitive. It helped the students work hard on their project and go deep into the concept. The competition persuaded the students to be more independent and responsible about their work. We applied many different skills in this competition, mainly teamwork and self-dependence. It also gives the students the courage to search for more topics independently. In this project, we faced some obstacles that were slowing down our work. One of the main obstacles is that this is our first time doing such a project, so we were kind of lost and not knowing from where to start. But we passed this through teamwork and the help of our teacher. Finally, this was a really fun and entertaining experience, and I hope to do better next time. Thank you.
Thank you very much, Yasin. Now thank you for the whole group for all the work that you did. Great project. Now we'll move to project number two with another group. Let's see will be this group now.
Hello everyone. Today we will be talking about trigonometry and how we use it in our daily lives. It is a very important branch of mathematics that is being used every single day. It is also the basis of many things that we make and create. Today we will explain the history, real life applications of trigonometry, and careers that make use of it.
I think it's not clear. I will try to open again right now.
Hello everyone. Today we will be talking about trigonometry and how we use it in our daily lives. It is a very important branch of mathematics that is being used every single day. It is also the basis of many things that we make and create. Today we will explain the history, real life applications of trigonometry, and careers that make use of it. Trigonometry plays a huge part in our lives, since many things depend on it without people realizing. This is the exact reason we have decided to choose this topic. These are the contents in this presentation. Muhammad Hassan will explain the origins of trigonometry.
The word trigonometry is a Greek word which originates from trigonon and metra. It was made centuries ago and was used in different ways, like identifying the missing angle using the two known sides or angles.
And this method evolved and was used in lots of nations like the Egyptian, Babylonian, and Chinese. They possessed a considerable knowledge of practical geometry that included some concept of bases of trigonometry. The Rhiine papyrus, an Egyptian collection of 84 problems in arithmetic, algebra, and geometry that was made from about 1800 BCE, contains 5 problems dealing with the secant.
A close analysis of the text with its accompanying figures reveals that this word means the slope of an inclined, essential knowledge for huge construction projects such as pyramids. Scientists didn't keep that method, they developed it. Trigonometry in the modern sense began with the Greeks. Hipparchus was the first to create a table of values for trigonometric functions. He called it considered every triangle as being inscribed in a circle so that each side becomes a chord that is a straight line that connects 2 points on a curve or surface.
Heron's formula, also referred to as Hero's formula, gives the area of a triangle when the length of all three sides are known. Unlike other triangle area formula, there's no need to identify the angles or other distances in the triangle first. It is also used to find the area of oblique triangle. Here's one of Heron's formula. S equals A plus B plus C over 2. And the area is square root S multiplied by S minus A multiplied by S minus B multiplied by S minus C. Law of cosine. It is used to find the distance or the inclination between two objects. Angle A represents the inclination between the two planes and the airport. So here we are going to use a real-life application by using the law of cosine. So first we are going to replace the variables. 189 squared is equal to 168 squared plus 244 squared minus 2 multiplied by 168 multiplied by 244 cosine A. So angle A is equal to inverse cosine. Then we divide the variables 189 squared minus 168 squared minus 244 squared divided by negative 2 multiplied by 168 multiplied by 244 is equal to degree 50.
Trigonometry has improved over time, since many scientists and students were learning this new branch of mathematics, which led to its advancement just like every other field of knowledge. It also spread to different places and civilizations, such as ancient Egypt, Europe, and the Middle East.
Trigonometry today is used more often than in ancient days and in lots of different ways. It's known now as the study of relationships in mathematics involving length, height, and angles in different triangles. Scientists developed this method and made three basic rules, and it's called sine, cosine, and tangent. These methods were used in lots of different careers.
Trigonometry simply means calculations with triangles. The field emerged during the 3rd century BC. From applications of geometry to astronomical studies, trigonometry spreads its applications into various fields, such as architects, surveyors, astronauts, physicists, engineering, and even crime scene investigators.
There are many careers that take advantage of trigonometry, contrary to popular belief among students in schools. There are many uses of trigonometry in many fields of work as well as real-life applications. We will also be talking about how careers use it in a different ways. For example, engineers use this method in buildings. Astronomy uses trigonometry to identify the distance between stars. Physicists use trigonometry to find the components of vectors and model the machines of waves.
Trigonometry has many uses and can be applied in engineering, mathematics, trigonometry is used in construction, as well as many other fields. For example, a carpenter wants to measure an angle in order to cut precise angles. This is to ensure that every part fits perfectly as intended. They would achieve this using formulas such as the Pythagorean theorem. Trigonometry is necessary for construction as well. It is used to measure fields, areas, making walls parallel or perpendicular, and roof inclination. Without trigonometry, the construction of buildings in this scale would not be possible nowadays.
Connection with other subjects. In physics, trigonometry is used to find the components of vectors, model the mechanics of waves in both physical, electromagnetic oscillations, the sum of strength of fields. Even the projectile motion, you have a lot of application of trigonometry. For example, you throw the ball straight upward or you kick a ball and give it a speed at an angle to the horizontal coordinate. or you just drop things and make them free fall?
Trigonometry is used in video games in order to create terrains and playable areas as to create game engines, which play a huge role in a game performance. The physics, graphics, and mechanics of games all depend on engines, which depends on trigonometry, since engines needs to be developed from the ground up and the software used to develop them requires extensive knowledge of mathematics. I have in this model a person standing 60 meters from the bottom of the building, looking 40-degree eyesight of the man and the distance between him and the building, which is 60 meters. And I want to find the opposite. So I'm going to use tan for this situation, so I can find the opposite, and it will be tan 40 equal h over 6. So we will, in this case, because we don't have h, we will switch the numbers, and we will take the variable to the other side, and the tan we will put it with 60. So it will be it will be 60 multiplied by tan 40, which equals 50.34 meters.
Reflection. We can easily recall the trigonometric function and the origin and history of trigonometry. Our muddiest point is that we had some issues while researching for some information about trigonometry.
In this PPT, we have learned about the origins, history, and development of trigonometry. We have also explored Heron's formula, as well as the law of cosine. We have covered the uses and application of trigonometry and how it benefits us. This was low sodium. Thanks for listening to our beautiful presentation.
Thank you very much. Group number 2 for this presentation and this video. I want to ask also one more reflection from the leader of this group, Muhammad Hassan. Give us a brief reflection for the whole group about the project, about your difficulties, what did you learn, and whatever you want to say about it. Please, Muhammad, can you start?
Okay, Mr. As all of us in the group are interested in engineering, this challenged us to choose this topic due to its importance. We learned as a group since the beginning, and we divided the duties till the end. It was a journey. We discovered and learned a lot of things as time management, teamwork, concepts of trigonometry, real-world application, daily life of trigonometry. We could improve our work if we were in contact with engineers to connect our skills. We faced the difficulty only in gathering and meetings, and others everything was well.
Thank you very much, Muhammad. Thank you for the whole group for this work, and hope you will have something better also in the future. This is just starting, and we are looking to improve from project to project. Thank you very much. Now we move to project number 3, and another group.
Hello everyone, I'm Wahid. Today, me and my teammates are going to talk about pi. Our project is titled The Essence of Pi. It goes through the history of pi and how it was developed. It also goes through different areas of science and mathematic uses of pi. And it also explains the fundamentals of pi. We choose this topic as we are very interested to know about the phenomenon of pi and its reality. We consider our math fair a great way to research the topic and to inform others about pi through project-based learning.
Okay, let's start with the basics. What is pi? Pi is a mathematical constant. It is the ratio between a circle's circumference to its diameter. It is used in many areas of mathematics and science, and it is used in basically anything that works with circles.
Now let's take a look at the brief history of pi. We are going to talk about most of the major ideologies of pi and changes of pi throughout history. So starting off, the concept of pi was first introduced by the ancient Babylonians around 1900 BC. It was then developed further by the ancient Egyptians around 1650 BC. Next up, Archimedes took part in developing pi using a new innovative method around 287 BC. Then, Zhu Chongzi, a Chinese mathematician, capitalized on Archimedes' method, developing it further at around 429 AC. Later, at around 1700s, William Jones associated a symbol that now stands for pi. Now let's look at it in details. How did the ancient Babylonians contribute in the development of pi as a mathematical constant? The ancient Babylonians used a method that involved rolling a circular object once and measuring the distance it traveled as shown in the animation. This gave them the circumference of the circle, which they can compare to the diameter of the circle and figure out the ratio. They got a ratio of 3.125, which is good enough considering it was found 4,000 years ago. How did the ancient Egyptians contribute in the development of pi? The Rhind papyrus was written by a scribe named Ames. His method involved cutting off 1/9 of a diameter and constructing a square upon the remainder. This gave them a square with a parameter of 3.16049. How did Archimedes contribute to the development of pi? Archimedes has been widely praised for his contribution. He created a formula that can find the most accurate representation of pi. It involved placing polygons inside and outside the circle. The vertex of the polygon inside touched the circle side, and the sides of the polygon outside touched the circle. After that, we should find the parameters of the two polygons and determine the value of pi, using a similar format of inequality. Using this method, Archimedes got a value between 3.14287 and 3.14084. As you add more sides to the polygon, you get a more precise value of pi. How did Zhu Chongzi contribute to the development of pi? Zhu Chongzi was a very famous mathematician. He used Archimedes' method but used polygons with 24,576 sides, which is a lot more than what Archimedes used. He got a very accurate approximation of pi, which is around 3.1428571. Lastly, William Jones' contribution in the development of pi. While William Jones' contribution wasn't similar to what others mentioned above, instead it was he who designated a symbol for pi, and the use of the symbol was then popularized by Leonhard Euler, who adopted it in 1737.
Now let's take a look at a physics puzzle with an unusual solution that computes pi. Here we have two sliding boxes and a wall. The first box starts moving towards the wall and hits the second box, which was initially stationary. This leads the first box to transfer its energy to the second box. Our goal here is to count how many collisions it takes for both boxes to move in the opposite direction towards infinity and never collide again. Let's start with the boxes having equal mass. The first box starts moving towards the wall and hits the second box on the way. This leads to the first box transferring all of its energy to the second box. The second box hits the wall and moves towards the opposite direction, then hits back the first box, making it move in the opposite direction to infinity. In this case, it takes 3 collisions to make the boxes move towards infinity. Now, what if the first moving box has a mass of 100 times the second stationary box? What would happen now? In this situation, when the first box hits the second box will keep bouncing back and forth until both boxes are moving in the opposite direction. In this case, we will have 31 collisions. What if we add 100 times more mass to the first box, getting it to 10,000 times the mass of the second box? In this case, we will have a reaction similar to the previous one, but more collisions. Here we'll get 314 collisions. What if we added more mass to the first box, getting it to a mass of 1 million times the second box? What would happen then? The reaction would be similar to the last one, but we would end up with 3141 collisions. After all of these, we can see that this puzzle is actually computing pi. But why? Although we don't see any obvious circles, but in reality there has to be one. That hidden circle is the law of conservation of momentum. Why is this? The simplest answer is that the conservation of momentum is a continuous loop of changes in a system. That's why it's showing pi. Putting all of that behind, let's talk about the importance of pi in our life. Pi can be seen in almost every part of our life. It is involved in anything that has curvature. Everyday use of pi can be seen in aspects like navigation systems, geometry, and engineering. Pi in navigation. Aircrafts usually fly in paths that are curved. The length of this path has to be measured using pi to determine the quantity of fuel required. This is due to Earth's curvature. Pi is also a requirement for the functioning of the GPS. Pi in geometry. Calculations related to any curved object requires pi. Surface area of cylinders, cones, spheres, etc. all require pi. This means anything in constructions like pipes, bridges, highway curves require pi. Pi in engineering. Many engineering formulas require pi. Whether it's aeronautical, civil, or electrical engineering, they all use pi in one way or another.
Reflection regarding the project. Doing the project was a lot of hard work. It was also very fun and entertaining because I got to learn more about pi and how it was discovered. I also got to do it with my classmates, which was very interesting and amusing.
My reflection on the project would be very positive, as I got to learn about pi in depth and I'm also getting the opportunity to share my findings with many others. I've learned about things that changes how I think about pi and lets me understand concepts related to it a lot better. The hard work and teamwork really adds to the feel that we have achieved something significant through this project.
My reflection regarding the project was very fun. It has a lot of interesting things about pi and its history and where do they use pi and for what. And we did a lot of hard work and research about these topics and we are very interested to like share those things with other people to tell them about pi and its history.
Thank you, group, for this nice project. I want to add one more reflection from the leader of the group, Hassan. Tell us also another reflection or a brief reflection about the whole group since the beginning of the project till the go ahead, Hassan, please.
Okay. The process of doing the project was very eventful. It involved getting to know a lot of new information that changes how we think about pi. It gave us a more diverse view of pi, considering the fact that it is used in aspects beyond geometry and engineering. We also got to know about the history of pi and its development, which lets us understand it from a different perspective for what it really stands for. Overall, doing the project was really, a really great experience. Thank you.
Thank you very much, Hassan. Thank you for the information you gave us. I am happy that we are having different topics today from boys and girls. We saw trigonometry topic twice, trigonometry project. Also, we saw circle project. We saw graph and the chart project. Now we see the pi also. And the last project today will be about the history of algebra and how was the progress in math from one civilization to another. And this is showing us the connection between math and the history over the past year. So let's go now to project number 4 for today, and it's the last group about the algebra, history of the algebra. Let's start.
Good morning, Morning everyone, I am Muhammad Omar and today me and my classmate Nasibullah decided to do a research on Al-Khwarizmi and how did he discover algebra and what are his contributions towards algebra. So first of all we chose this topic because algebra is the heart of mathematics and people think that algebra was invented by a Western or by an European, but the fundamentals were invented and discovered by a Muslim scholar named Al-Khwarizmi. And we also chose this topic because we wanted to know how the algorithm was invented or discovered and how was it implemented into technology and devices we use today. So before we move on to the contributions of Al-Khwarizmi, let's talk about Al-Khwarizmi. Who was Al-Khwarizmi? Al-Khwarizmi was born in Baghdad about 780 AC and died in 850. He studied at the House of Wisdom, which it was founded by the Khalifa al-Ma'mun, where Greek philosophical and scientific works were translated. His task there involved the translation of Greek scientific manuscripts, and he also studied and wrote an algebra and geometry and astronomy. And now we'll be talking about the first book of algebra. The first book was named Hisab al-Jabr wal-Muqabla, was the most famous and important of all Al-Khwarizmi's works. It is the title of this text that gives us the name algebra, and it was the first book to be written about algebra. It was written in Arabic.
So before we move on to different parts of this topic, let me explain the importance of algebra. Why do we study algebra? Algebra is a branch of math, as we all know. A lot of careers today demand skills like problem solving, reasonings, and decision making. Hence, algebra plays an important role in those skills. Not only that, but algebra also builds a better brain. I want you to have a look at the picture and point the difference between a brain with stimulation and without. Now, you might ask how algebra is connected to that. Well, it is very correlated. When the brain is stimulated to think, the hair-like dendrites of the brain grow more extensive and more complex, enabling more connections with the other brain cells. You often hear that we use only a small percentage of our brain's capacity. The study of algebra is a way to increase our use of this marvelous muscle. By studying algebra, more highways are built upon which future cargo is transported. Cargo other than algebra. Even if you are not looking at complex mathematical formulas every day, you are still surrounded by them. The algorithms, which is part of our daily activities, like taking an Uber pool, using Spotify Discover playlists, and typing something on Google. It is possible we wouldn't be here without the contributions of the early 19th century Persian mathematician Muhammad ibn Musa al-Khwarizmi. The word algorithm is actually derived from a Latinized version of al-Khwarizmi's name. Further, the word algebra is drawn from a portion of the title of his most famous book, which is called, as you can see, Al-Kitab al-Mukhtasar fi Hisab al-Jabr wal-Muqabala, translated to as the Compendious Book on Calculation by Completion and Balancing. Muhammad started his career in the House of Wisdom in Baghdad as a translator, whose main role was to translate the major mathematical and astronomy texts from mostly Greek and Indian to Arabic. He was soon promoted to become the director of the House of Wisdom. As he pursued all the problems, theories, and rules presented in the text he was translating, he realized that there might be a simpler way to problem solve. Now, his first approach was to look for a solution or switch to a Hindu numeric system from 1 to 9, which would simplify the language used to dissect problems. Khwarizmi, as a solution to look for a simple language to dissect problems, he created these Hindu Arabic numerals from 1 to 9 and 0. Now the first number, 1, it has one angle. The second, it has two angles. The third, it has three angles. Based on the angles, he invented these numbers. And 0, because it has no angles. Secondly, he developed a more general way of analyzing problems in an abstract mathematical language, which is now we call algebra. But don't accept Al-Khwarizmi's algebra to look anything like our algebra. Muhammad's seminal work, written in 1830 AD and considered the foundational text of modern algebra, did not include symbols of algebraic notation as we know them today. He only explained problems with words and used diagrams to solve them. But the book's usage of fundamental algebraic methods of reduction, completion, and balance were new. Reduction is rewriting an expression in a more simple terms. Completion is moving a negative from one side of an equation to another and flipping the other side's signs. Balancing is the process of solving an equation by doing the same operation on both sides of the equal sign. The discovery of this method wasn't Muhammad's ultimate conclusion. He posited that we could use these methods to solve exceedingly complex problems in easier ways. Now the Chinese mathematicians, they were able to solve some quadratic equations, ones involving variable to the power of 2, but it was through complex methods that weren't easily digestible or understandable. Therefore, Muhammad used completion and balancing to reduce the quadratic equation to one of the six standard forms which we know today. The director of the House of the Wisdom contribution to mathematics broke new ground in the day, and the shockwaves of these discoveries to our daily lives now. Hindu Arabic numerals were soon adopted by the entire Islamic world, and then later with translation of his work into Latin were adopted by all Europe as well. Muhammad's These are some of the other contributions of Al-Khwarizmi to math. He explained the use of zero, he developed decimal system, he developed several arithmetical procedures including operations on decimals. He developed in detail trigonometric tables containing sine functions and tangent functions. He developed calculus of two errors which led into the concept of differentiation. Al-Khwarizmi's work also influenced Leonardo of Pisa. He was the greatest European mathematician of the Middle Ages. His full name was Leonardo of Pisa. He discovered the enormous practical advantages of zero and decimals system compared to the Roman numerals, which was still current in the Western Europe. This presentation was mainly about the contribution of Al-Khwarizmi to the field of mathematics. He played an important role in inventing the fundamentals of algebra. During this project, we found out that there was very little information available for us to make our research on Al-Khwarizmi. Hence, it made it difficult for us to conduct or finish this project. Most of his books were either lost or the Europeans stole the knowledge. We learned a lot about the fundamentals of algebra and how it was implemented into people's life at the time and now. And most importantly, we discovered the important role of a Muslim scholar in mathematics field as we know today, algebra. That was my reflection, and thank you.
Now I want to ask also one more reflection from the group leader, Nasir, about this. I think it's historical project more than mathematical project. Yes, Nasir. Can I start?
Good morning, my name is Nasib. In grade 11A, it was an enlightening and interesting competition for me as a learner. It was enlightening because we were asked to make an extensive research on different topics of math. This exposed us to a lot of information, and of course, we gained a lot of experience and information. We worked collaboratively with other members of the group throughout this project. We came across many obstacles, such as choosing the right topic for our presentation, but we eventually agreed upon one topic and we went ahead with it. Not only that, but also we faced many difficulties in finding resources and information for our topic. It took a lot of time to gather our resources, but we learned an important skills from this project, which are teamwork and research. We were able to think of different ways of implementing this topic into our lives. I think this competition improved me in many areas and I'm happy to participate in it. Thank you.
Thank you, Nasib.
Thank you very much, Mr. Naseeb and other leaders. Thank you, Mr. Omran. Do you have more project, Mr. Omran?
No, this is the last project.
This was the last one. So we have Miss Shiraz and she has a class. So she has something to say as reflection. Miss Shiraz, can you unmute?
Yes, please. Thank you, Ms. Nikhat. Thank you, Mr. Omran. First of all, I would like to thank the math department for this great experience that we are learning from. Big thanks to my dear students who show today they are up to the level and above level as well. Well-organized presentations from the beginning, from the process to the steps to the fraction as well. What I like the most, smooth responsibility divisions, great teamwork spirit, good presentation skills up to the college readiness, and I'm proud to see this today. Good implementation and integration to real life and other subjects. I like the self-evaluation that it shows that the students are aware of their target, of their goals, and of their weakness and area of development, as well as their strengths. Just briefly, good effort from the student side, professional guidance, Mr. Omran. It shows, that your students are up to the level of the good teachers and very good teachers in some cases. So thank you so much for this. My dear students, looking forward seeing more innovative and excellence in your senior year. Thank you so much. You have done a great job. Thank you, Ms. Nakat, for the opportunity. Thank you, Mr. Amran.
Most welcome, Ms. Shiraz. Thank you very much.
I insisted to attend, to
Yes.
give my reflection for my students and for you and Mr. Amran. Thank you so much.
Thank you, Ms. Shiraz. Yeah, you really and critically maybe you was observing here and there. And during this time, I know you have period and you was quite busy. But thank you very much for your time and for your reflection. And good job, boys. And now we have Vice Principal Elementary School, Ms. Khatija. Ms. Khatija, would you like to unmute and provide your reflection? Ms. Khatija?
Okay, yeah. Thank you, Dr. Nikhat, for inviting us for the very well done, very well prepared math exhibition. Actually, I attended for a short time here. I was very happy to see the confidence from the students' side, the very well preparation that they have gone through. And of course, this will never happen without Mr. Omran's guidance and your guidance as well. As Ms. Shiraz said, I agree with her. The presentation skills of the students, mashallah, it was amazing. They were very confident. All the information that they have prepared, I myself learned things that I haven't knew before. So thank you very much, the math team. Thank you, Mr. Amran. Thank you, grade 11. You did a great job. Thank you so much.
Thank you very much, Ms. Khatija, for your time and your feedback. And really, students, they did amazing job, and their research shows they are ready for college. Now I can see Ms. Margaret here, Vice Principal for KG section. Ms. Margaret, would you like to share your reflection with the team?
Yes, Ms. Dr. Nikhat, thank you for inviting us. Even though it was a short period, I was able to attend just a few minutes here. What I could see is it was a well-planned, research-based presentation about great mathematicians, and that few minutes that I was here, I could see that it was a well-guided project based learning presentation by the students, guided by a excellent teacher. So good job, Mr. Umran, and because you have been supported by none other than Dr. Nikhat, so that perfection we could see the area of perfection from all areas. So students, you are lucky to have good teachers and support. So thank you for inviting us and presenting your work. Well done. Keep up your good work and keep up your skills and keep developing these skills wherever you go. And thank you, Dr. Nikat, once again.
Thank you very much, Miss Margaret, for your feedback, and of course, your words will give a lot of encouragement to students. These are grade 11 students, and I'm sure when they will be in grade 12, I'm 100% sure they will do some work, something like scientists, and they will invent something which we can offer to someone outside the school boundaries. We have Mr. Ridwan here from high school. Mr. Ridwan, would you like to unmute and share your reflection?
Yes, Doctor. First of all, thank you, Mr. Imran, for your effort. Honestly, students are showing very, very progress. The progress of the student are like showing clear in grade 11 compared with my student in grade 10. Uh, uh, Nice way to present, and I really like when they talked about the Khwarizmi. Okay, they really need to know who's invent the algebra, or the first one who invented algebra. So thank you, Mr. Imran, for your hard work. And yeah, that's it. This is my reflection.
Thank you very much, Mr. Ridwan. Of course, this will help student to look forward for the next grade level because time is quite short. I can see Mr. Rashid here from middle school. Mr. Rashid, would you like to share your reflection?
Hello, Dr. Nigat. First of all, I'd like to thank Mr. Amran for his wonderful efforts with his students. And second of all, even though that I joined like for a few minutes at the end because I had some invigilation going on, I could see the level of professionalism that went on in this project. The level of detail and the level of accurate information that was given by the students is actually college worthy. I can never stress enough about how the high school students actually put their work into the they work from their hearts and their work is actually acknowledgeable by everybody. I wish them all the luck, Mr. Amran. I give you my deepest respects and acknowledgement because you're a wonderful teacher, and thank you for this wonderful project. And good luck to all the students in their university. I hope you all very well.
Thank you very much, Mr. Rashid. I know you have MAP in middle school and you are busy the whole day, but you got chance to take this opportunity to come in this exhibition, join and reflect on students' work. And thank you everyone, all the guests and students, Mr. Umran, everyone, thank you very much for your effort and thanks for your reflection. Mr. Umran, would you like to say something?
First, thank first for you, Mr. Dr. Nigat, Ms. Margaret, Ms. Khadija, Ms. Shiraz, Mr. Rashid, and Mr. Radwan for all the feedback. Thank for all the people who support inside the school and outside the school. I am very happy for what the students they did. And as I said, this is the first time we do a project this size. It's big size, not small size. Not just a video of 10 minutes. The students they work for more than 3-4 weeks. Here and there, meetings, models when it's possible, PowerPoints, making the video. So this was not easy for all of them. Having something like this, I think it's positive. Wishing in the future, grade 12, maybe as Mr. said, the college, university, they will have projects for sure. They will improve from one project to another. Thanks for everyone. I finished from my side. Thank you.
Assalamu alaikum.
Wa alaikum assalam, Miss Afra.
Yes, I am Saleh's mother.
Welcome to Math Exhibition.
Yes, how are you, Miss?
I'm good. How are you?
Fine, alhamdulillah.
I'm looking for your reflection, and I'm sure you are from the beginning. Miss Rasha told me you already joined the session. Thank you very much.
I'm joined from the beginning. I am and his father, but his father left just he joined for 30 minutes, and
All right.
because he is in his duty. That's why.
Of course, of course.
I'm really enjoy and I'm really proud of my son and all of the students. Mashallah, mashallah for all of them. They get good information and they are really ready for to join for university, inshallah. And they have, mashallah, good knowledge and good information for everything for and how they will use the math in our life cycle. And good luck for all of you. And I wish all of you be in the first for everything. And I'm really proud of all of you, all of you. Not only my son, all of you. Mashallah, mashallah. Good presentation. And thank you, Mr. Imran. You invite us to join this presentation. Thanks for everything.
Thank you very much. And I'm really so proud and happy because parents' involvement is very important in a student's learning journey. And really, if you join, and I know, of course, you will be busy and your husband will be busy, of course, but you was able to manage this time. I'm really so proud to see you here, and I'm really so happy for your kind words and your reflection. And this will give a lot of motivation to all our students. Thank you very much, Ms. Afra.
You're most welcome, Ms. Nikal. You're most welcome.
So thank you, everyone. We have finished everything. So this is the time to wrap up the meeting. So goodbye, everyone. Assalamu alaikum.
Alaikum assalam. Thank you. Bye.